Hi, I'm John Michel, and I'm Director of Marketing for Juniper's Cloud Ready Data Center, and welcome to MWC Barcelona 2023. In this demo, we're going to be focusing on Juniper's automated data center. Imagine that you're a service provider, We Connect, and you've got thousands of locations around Europe, particularly here in Spain, and you're trying to roll out a new video service before MWC Barcelona. What do? Well, it's pretty difficult to do if you are doing it manually, almost impossible to do anything like that at telco scale. So we're going to use our automated data center tools in order to simplify the deployment and make it easy for you to get these products out the door. The automated data center is built around an intent-based model so that you don't have to worry about CLI. It's reliable, so it's repeatable, and it's multi-vendor. So you can decide on the products that you want to deploy based on, let's say, port density, performance, cost, or maybe it's a supply chain issue and you need to look at an alternative vendor. So what I'm going to do in this demo is I'm going to walk you through developing a rack, deploying virtual networks across a multi-vendor rack, and then how we deploy telco services across a high-performance server and do it in record time. We're going to start off with deploying Apstra. Apstra is our multi-vendor data center IP fabric tool. It allows you to take what would normally take days, possibly weeks, and do it in minutes. So we're going to deploy a rack. So here we have We Connect trying to deploy a new video service, and they need to add racks to their different locations. So again, We Connect as data centers, they have telco clouds, they have edge clouds all throughout Spain. If you're going to do something like this, it's possible to do it manually, but it's impossible to do anything at telco scale when you're dealing with CLI. I'm going to show you how Apstra does it. We currently have in this particular location a 2-spine environment with 1 leaf. What we want to do is we want to add 2 new leaves to this, and we're going to use templates in order to do it. So you don't have to configure this manually. You can define those templates. Those templates are incorporated into and delivered through Apstra, and we can apply them without a whole lot of product knowledge. So we go to racks, we're going to go add rack, and here we're going to select from a set of predefined templates the type of rack that we want to deploy. In this case, it's an EVPN ESI rack, which is kind of like multi-chassis lag. So here we're adding the 2 leafs. We have a dual connected server and then 2 single connected servers. Now we're going to add this into our existing environment and stage it. Next, we have our topology. So now we've added the 2 leafs to our existing environment, and we need to drill in and start to add the products. So at this point, we just have the topology. We haven't picked any platforms yet. So what we're going to do here is start with the interface map. The interface map defines the number of ports, the type of ports, are these uplinks, are they access interfaces? It's not defined based on vendor type. So in this case, we're going to go in, we're going to select from a set of menus, and you'll have these drop-down menus that allow you to pick the type of interface map that you want. In this case, we're picking a QFX, and by default, it's going to pick the platform as a QFX itself. Next, everything gets staged. So in this case, we can batch everything. So theoretically, you can build your topology, have it ready to go, but you can do it without having a single product in-house. This allows you to streamline the process of getting your deployments ready, and once that equipment ships on site, you can deploy. So here, Apstra goes through a check process where we validate the configurations, we commit those configurations to a live network, and we converge. So you're ready to go. Now, we have the topology, but now we got to add virtual networks to this environment. These virtual networks are going to add compute storage and networking so that we can extend our service to a broad customer base. We're going to do this without any CLI. So when you're adding any type of network or racks to your system, there's a whole lot of things that you have to do. You've got to define your topology and your connectivity. You've got to define network IDs and IP addresses. You have to design your routing environment, and then you have to type it out. But not if you use an Apstra. Apstra allows you to do this without understanding or knowing CLIs, which is great when you have environments where you're not sure which products are going to be in demand, and you're not sure what expertise that you have in-house in order to deploy the product. Let's add this capacity, and we're going to use Apstra to do it. So we're back in another environment where, again, we have 2 spines, we have 3 leaves. This is a multi-vendor rack, so we're just going to drill down a little bit into this existing deployment, and we see that we have an Arista pair on one side, And then we're going to drill down into leaf 3, and we can see that this is a Cisco device. So now we're going to define our virtual network. So in this case, we go to our Add Virtual Network screen. So you can see that we've got a name for the virtual network, it's Finance. We're assigning it to an existing routing zone called Finance. And I'm going to leave these two entries blank right now, the VNI and the VLAN ID, just to show you how Apstra goes through to validate configurations before they're deployed. We're going to pick the different types of configurations for this particular deployment, DHCP services, v4 connectivity, gateway addresses, etc. Is it tagged or untagged? And then we're going to define which switches we actually want this virtual network to be applied to. If you're building a virtual network, you don't necessarily want to send it out rogue to every single switch. You want to be specific so you can kind of improve your security and reduce your blast radius. So here we're going to put it on both switches, but we can get a little more granular in the next set where we can then define the ports. We've added our virtual network so we can see it's Finance. We have our VXLAN, but you see something shows up as red. Red just means that there's a configuration that's incomplete or there's an error. So here we can see we have to add the VNIs. So we're going to pick from a pool. We're going to add the VTEP. Again, we're picking from a pool, and then we can go in and define which ports of those switches that we've defined are going to actually have that virtual network. Now we're staged. We want to take a look at the configuration. So we're going to drill in a little bit on, in this case, an Arista switch. Now, I don't know anything about EOS. Apstra has rendered the entire configuration based on the intent that we've defined leading up to the stage. So there's no CLI work. Apstra renders that configuration. It'll do the same thing for iOS. It'll do that, obviously, Junos and others. We then stage it and we commit it to the network. Once it's accepted, the network is converged, we turn green. We want to add a telco workload. Now, telco workloads a lot of times require very high performance. So these workloads need to be deployed in an SRIOV host. So these workloads plug directly into the IP fabric. In order to connect those workloads and those networks in the underlay to workloads that are deployed by Kubernetes and through the overlay networking in SDN. For Juniper, that's our cloud native Contrail networking, or CN2, which is, again, it's an SDN and CNI built into one. You need to manually stitch those together up until now. So what we've done is created a CN2 and Apstra plugin. And this plugin allows you to stitch these ships in the night networks together without creating trouble tickets or doing things manually, which can result in errors. So let's walk through adding, in this case, a charging function for this video service that we're deploying here in Barcelona. So first, we're going to take a look in Apstra. We're just going to show that there's an existing rack, but we don't have any existing virtual networks, and we don't have any existing routing zones. So it's a blank slate. So now let's go into the web GUI. The web GUI lets you define the interface into Apstra. So you put in your credentials, the location, IP addresses, the blueprint that you're going to be using. And this instantiates the plugin so that Apstra and CN2 can communicate with one another to actually automate the building and stitching of those virtual networks that are both SRIOV hosted and non-SRIOV hosted. So the first thing we're going to do in, again, the CN2 GUI is we're going to define the network attachment definition. Now, this is the same network attachment definition that you'll see with Multis and CNI, and we're looking at net 20. We're just going to drill down. In here, we have a YAML file, and we have our own embedded YAML editor, and we can define what that network would look like so that when workloads are brought up on SRIOV, we can either dynamically build the network to attach that SRIOV host, or we can attach that new pod to an existing network. Now here we're going to look at pod 20-1, and we're going to open it up. Now this definition we're going to augment, and we're going to add in it the NAD definition. This NAD definition becomes a trigger so that when the pod is created, Apstra sees that net 20 references the plugin itself so that the network gets automatically built. So now we can drill down from CN2 to look specifically at the state of that network. We've created the pod. The network is existing here in CN2, but the network is also existing and connected in Apstra. So we can see all the state, all the connectivity, and that everything is working and everything was automated. We didn't have to issue any trouble tickets or do any manual configurations in order to stitch these two networks. To wrap things up, Juniper's automated data center is intent-based. So again, you don't have to worry about CLIs in order to operationalize a network. It's reliable, meaning that it's repeatable. So the processes are there, they're baked into the workflows, and it creates consistency in your deployment models. And it's multi-vendor so that you can pick products based on your criteria.